to Python coding lesson 5. In today's lesson, we're just going to continue with the if statements and we're going to start off our little looping structures. Right, so before we start off with that lesson, let's look at what we did yesterday. Yesterday, we answered the question to write a program for a person that enters in the age and determine whether they can vote or not, as well as to generate a random number from 1 to 10 and indicate if the guess was right. Left you with this little program to do for yourselves to create a guessing game for rock, paper, scissors. I'm going to go through that code now to see if you manage to do it. Right, so if we look at the game rock, paper, scissors, yes, we can let the person enter in what they want, like rock, paper, and scissors. But to make life easy for us as coders, what we can do is we can give each item a number. For example, let rock be 1, let paper be 2, and scissor being 3. So I can give numbers to each of the items. All right. So, okay, let's start with that program there. So, paper, scissors. I can start. Right. So, if we look at this in this game that we're going to be programming, the person is going to enter in, and I'm just going to write it out here. The person is going to enter in 1 for rock, 2 for paper, and 3 for scissor. That means if we know what each of the items is going to be representing, we can now break this program down into how to actually solve it. So let's go with this. So if they enter in 1, and that's rock, and we know that rock beats paper. Sorry, right. Rock beats scissor. Right. And we know that paper beats rock. Final outcome is scissor beats paper. So if we look at this, we can now, since we know what each one represents, we can say, okay, so if we have the number 1 beats, and scissor would be 3. Thus, depending on how you programmed it, is slightly different. So if we programmed paper is 2, then 2 would be rock. So rock is 1. Finally, 3. 3. Right, 3 will be to paper. Paper is number 2. So now we can look at how we're going to create those if statements to do this. Okay, so let's start with our input firstly. And with our input this time, I'm going to put down some lines of code firstly. And the lines of code I'm going to put is actually going to be the output part of it. Just to make a little display so that the person knows what we're talking about. So I'm going to go screen off. Okay. There we go, back on. Right, so welcome to the game, rock, paper, and scissors. So that the person knows what each choice is. we'll put down something like 1 is for raw. Just copy and paste this and just change a bit. So 2 and 3. Okay, so 2 is paper and 3 is scissor. Now we can say the person, all right. So we can now put down our input part of it. The input is we're going to get what the person's choice is. So we can go, okay, the user choice is equal to the input. So say, okay, enter in your choice. The person is either going to enter in 1, 2, or 3 because that's the numbers that we've allocated it. So I can go, okay, since I'm going to be comparing this number that the person enters with my own numbers that the computer is going to choose, I'm going to have to convert it. So I can say user choice is equal to int. Convert user choice. Now I got the user's choice. I now need to make the computer generate a number for itself, for its own choice. In order to do this, I'm going to go back to the top here. I'm going to say, okay, since it's going to be a random choice, I'm going to have to import the random statement. So I'm going to go import random. So now that I've imported random, I can use the random for the computer's choice. So I can go computer choice is equal to random dot rand range. And we only got 3 options. Let's start off at 1. Let's go to 4. Remember again, the last number in rand range is not included. So this numbers will only generate the options of 1, 2, or 3, nothing else. Now that we've got our computer's choice, we can then start and look at the different types of options of who's going to win. Now there's multiple ways to check who's going to win. So I'm going to start off with the easiest one to just check if the person wins. So this code that I'm going to write off here is going to be for user wins. Right, so enter, so it brings the code up. So how do I check if a user has won? I go, okay, if, and I'm looking at the options I've chose there. If the user has 1 and the computer has 3, then the user wins. If the user has 2 and the computer has 1, the user wins again. The computer has, the user has 3, computer has 2, the user wins. So those are the options when the computer loses or the user wins, the person that's playing the game. So now it's time to code it. So we go, okay, if the user choice is equal to 1 and the computer's choice is equal to 3, then that means the user has won. So I can write down, okay, print, everything. Congrats, you beat the computer. Maybe if I wanted, I can go and say, okay, before this line here, print the computer selected. Since 3 is scissor, I can just put in the word scissor instead of putting the number 3. Remember, the person chose rock. Now, the rest of the statements are going to be similar to this because I'm only changing around the numbers. And of course, the statement on the inside. So what I'm going to do is I'm just going to be a bit lazy with this, and I'm going to copy the code because why should I write out the entire thing if I can just copy it and paste it and just change a few things? And that's allowed in programming. And so our change becomes 2 and 1. This becomes 2. This becomes 1 for the win. And now the computer hasn't selected scissor. The computer selected rock. So I can take out scissor. I can put rock. Then the next option is 3 and 2. So I can go, okay, 3, 2. But this time the computer chose paper. I can go, paper is the choice. Quickly save. And I can quickly run this to see if maybe we win on the first time invalid steps. Oh, right. I keep making the same mistake. Remember, when we comparing items, it's not a 1 equal to sign, it's a double equal to sign. Double equal to sign means comparing. Sorry. So I'm going to run this now. There we go. Enter the choice. I'm going to go rock. The computer chose selected scissor, and I won. Of course, that's first time I won because I chose the right one. But of course, if I choose the wrong one, and you can see nobody wins here because there was no output if the computer wins. So it's now time to program what must happen if the computer wins. So we can just copy and paste that here. Change this part to say, okay, computer wins. How to determine the computer wins? By simply swapping around this values. Because remember, the user wins. We worked it out on the top. 1 and 3, 2 and 1, 3 and 2. Those are the options for winning. So to check if the computer wins, all we have to do is swap around the values. So now we go, okay, if the not the user's choice, if the computer's choice is that, I got a capital C there, and to put that back as a small one. Right, so now and to check now, because the person is going to lose, I'm going to have to put user on the other side. So now I'm checking if the computer is winning. So I put in the computer first. So that's going to become user. And now I can change my outputs. So this time, the computer chose 1. This is now rock. Computer chose 2. This is paper. Computer chose 3. This is scissor. So now it's no more congrats, you beat the computer. Say sorry. Sorry, the computer as one. I'm just going to copy that, paste the other outputs. It's going to read that entire thing. If we quickly run this little program, and my choice is now 3 again. The computer selected rock. Sorry, the computer has 1 because we selected 3. 3 was scissor. So now we have a game where you can burst the computer and see how many times you can beat it. Now you'll notice that every time we have to do this, so every time we want to play the game, we have to actually restart it. So we have to come here and press F5 or click on run and run the module. Nothing stops you from copying and pasting this code and doing it 3 or 4 times and seen if the person has won or not. But eventually we learned that there's a faster way instead of copying and pasting to repeat code. Right, so I'm going to leave that just for a little while. I'm going to come back to it. Right, so if we look at the next part, the logic operators we went through yesterday. With the logic operators, I explained that's the AND function. Both sides of the statement must be true in order for us to have an outcome of true. That means if I look at the example, I say A is 3, is A less than 5? This is true. Is A less than 10? This is true. Since the left part of AND and the right part of AND both has true in it, our answer, our final answer becomes true. Because our final answer becomes true, it will run the program. What happens when one side is false? Well, if we look at 6, this becomes false. A is not less than 5, it's actually 6, but it is less than here. So we have a false and we have a true. A false and a true will give us a false answer, right? This applies a bit like how you learned in maths, the positive and negative numbers when you multiply them. Two negatives make a positive, right? But then if we look at the OR statement tells us as long as one part of your condition, the part that you test in, is true, it makes that entire statement true. So we look at this. This is false on the left-hand side. A is not less than 5, but A is less than 10. So the right-hand side becomes true. But because we're using OR doesn't care which side is false. The only thing OR cares about is as long as one side of your answer is true, it'll give you a final answer of true. So OR will always work as long as one part of your condition is correct. So that's what we talk about as the OR statement or the OR operator. First, I spoke about the NOT operator. NOT operator reverses the outcome, meaning if the outcome was supposed to be true, it'll give us a false answer. So our answer was supposed to be false, it'll give us a true answer. So let's look at it. A equal to 6. Is A less than 5? False. It's not. Is A less than 10? True. That's correct. And if I look at this, false and true. False and true was supposed to give us an answer of false. Because with and, both sides must be true in order to get us a true answer. But we're going to get a false answer. And because we're getting a false answer here, we're saying not false. And not false will mean true. I know it's a little bit tricky there, but try to bear with me. Just we looking at how our answer is going to be with the conditions. And finally, the A is equal to 6. A less than 5. No, that's false. Is A less than 10? That's true. And if we look at this, it's or doesn't care which side is true. As long as one part is true, our final answer becomes true. But if I look at the final answer, it's telling me to take the final answer and say not. So if I say not true, the answer is false. So that's just what not does. It reverses our final answer. Right. So if I tell you you're not a boy, of course it means you're a girl. If you're not a girl, you're a boy. So that's what it means by not. Going on to the next part, let's try a little question with that. Write a program that will allow a learner to enter in their percentage. The program, sorry, that's supposed to be must then determine and display the symbol of the learner has obtained. So if you got 0 to 29 as a percentage, you got G. You got 80 to 100, it means you got an A. Any other percentage is invalid. So if you look at any other percentage, if I go and give you negative percentages, invalid. Give you more than 100, a report card, you can't have more than hundreds, that's also invalid. So let's start with that one. So we can quickly open a program, pass and fail. We're going to code for that. So we'd have to have an input, and the input is symbol. So I'm going to go SYM, short form, is equal to input what is your percentage. Now that we have the, well, I should just call this percentage. I'm going to display symbol. All right, so now that we've got the percentage, I can now convert it. So I'm going to percentage is equal to int and percentage. So now that I've got the converted percentage, I can start working with my process. Yeah, using all the symbols on my keyboard. Here we go. So if I look at it, if, and just go back, if it's between 0 and 29, it's a G. So if the percentage, and I'm just gonna do a little shortcut here. I'm going to leave it as a short form, so I don't have to type it out every single time. All right, so I can go here and say is percentage. So if anybody else is reading my program, they know what the per stands for because I just use short form. So if percentage is greater than equal to 0, and at the same time the percentage is less than equal to 29, and that means I must print the symbol is G. Now I can quickly copy this. I can paste it for each of the other ones. So the next one will be EF. All right, just gonna quickly paste it a few more times. I can do okay. Next one is greater than equal to 30. The next one should be 40, 50, 60, 70. I think we need one more. And 80. All right, good go. This one should be greater than 30, but less than 39. So 39, 49, 59, 69, 79, and look at the last one, it's 82, 100. So this must be less than equal to 100. Those would be my symbols. I'm going to go F, E, B, C, B, and A. So now that I got my symbols, so if I quickly just save this and run it, I can say, okay, percentage is 45, and I put, oh, use percentage. All right, I forgot to take out the percentage from the conversion. Remember, I short formed it. So I'm going to quickly run this again. percentage 45, the symbol is E. That's how we do the percentage one. Now I said there's another way we can do this. The alternate way to do this is I'm going to just create a new file, paste it again, save as percentage if. Right, so the alternate way to do this is if I know what my upper and lower limits are, oh, I forgot the last one. Yeah, come back to it just now. Right, if I know what the upper and lower limits are, I can say that if the percentage is less than 29, it's a G. And if the percentage is less than 39, it's an F. If the percentage is less than 49, it's an E. If the percentage is less than, I'm sure you're getting there. What did they say? It can be D, C, B, and A. And we look at what we learned the last time with the if statements. There was 3 different versions of it. This is going to be an if, else if. The reason for this is I must only check the next statement if the statement above it is false. Last one. So I must only check this statement if this one is false. I must only check this statement if this statement is false. I must only check if it's less than 59 if less than 49 is false. So that's how this would work if I don't want to use 2 positions. And this does the same thing as the last program. It's just that it has a slightly different part of it. Here we go. Symbol is E. The question to some of you might be asking, but what if we leave out the EL? What happens? You see, if we leave out the EL, it becomes a normal if statement. And with a normal if statement, it would check every single condition, no matter if the last one is false. So if I put 45, it's going to come and check, is percentage less than 29? You're going to say, no. Okay, let me just put it just so you know what I'm talking about. I put 45. Is 45 less than 29? No, so it won't display G. Is 45 less than 39? No, so it won't display F. Is 45 less than 49? The answer is yes. So if the answer is yes, it's going to display E. But you see, because this is not an else if statement, it's going to check the rest of the lines as well. It's going to come to the next one. Is it less than 59? Yes, it will display D. Is it less than 69? Yes, it's going to display C. That's what happens if we have a program like this and it does not have an else with it. It says the symbol is EDCBA because it satisfies all the above statements. That's why when we want to only put in one condition with a value, we always make sure that we only test the other ones if the value on the top was wrong. That's why this becomes a else if statement. So the else if only works if the top one is false. So it comes over here. It says, is my percentage I put in, that's 45, less than 45, 49? Answer is going to be true. So since the answer is true, it'll display E. But because this one statement was true, the rest of it will not run. The rest of the code won't be run at all. It won't read it. Why? Because all the rest of the code over here has an else with it. So it ignores it. That's why this makes it work. Because it'll only read once it becomes true. And then if it's not true, it will just go on. Right. I hope that you understood that a bit. Save that. Next part. The next part of code, I'm going to be showing you, well, I'm going to leave a little exercise for you to do and we can come back to it later on. But if we look at this exercise, Some learners at your school are having a problem to determine if they passed or failed a test. So they ask you to create a program for them to enter in their subject mark and the maximum mark. Your program must then determine and display if they have passed the test. Assume that in order to pass the test, they need 30%. So if we look at this question, just breaking it down, if we look at the inputs part of it, a person needs to enter in the subject mark. So they're going to enter in the subject mark and they're going to enter in the maximum mark. Your program must then display if they pass the test. So in order to know if you pass the test, our processing will have to be if that percentage they obtained is greater than 30, it means they passed. If it's less than 30, sorry, it's greater than equal to 30, they passed. If it's less than 30, they failed. So we need to know how to do that processing. That processing means you need to know how to calculate what the percentage is. And in order to calculate percentage, what we do is we normally take your mark, so what the person has, we take your mark, we divide it by the maximum mark, and we multiply this by 100 to get a percentage. And then once we've got this entire calculation done, we can store it in a variable called percentage. Now, after that, all we have to do is look at, is this percentage greater than 30? Sorry, greater than equal to 30. If it is, that means they passed it. If it's less than 30, means they failed the test. So if we have a bit of time today, I'll come back to this. But I need to move on to the next part of the work, right, which is looping structures. So if we look at this, design a program that will display the number from 1 to 10. Now, if I had to actually go and type this entire thing out, it'll be really simple and straightforward. All you really be doing is you'll be writing the program out like this. Print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you just have print and you'll be displaying the numbers. What if I come and say, okay, class, I want to change it slightly. Let's do it for 1 to 1,000 now. You'll go and copy and paste that and put 1 to 1,000. No, there must be some easier way to do this. And in programming, there is an easier way. And the easier way to do this in programming is what we refer to as loops. You see, loops allow us to repeat a block of code over and over, and it'll stop when we either tell it to stop, or it can stop when a condition is met. Now, the first type of loop instruction I'm going to teach you is where it'll stop when I tell it to stop. It'll repeat something X amount of times. And the first thing you need to know about this looping structure, so I can change this entire print statement into this looping structure, is we're going to have to learn another function. Conjunction with this means in together with this. And the syntax for the loop itself is as follows. For I, now I is just a variable. Collection means what is it that we are looking at? What information we're looking at? And when we got this information, we then indent our work and we put down what must be repeated. Just like with the if statement, when the if statement is true, this is what must be done. The for loop will work something similar to this, but it will only repeat items. Now, for those of you that don't know what a group of items are or collection, I've got two bits of collections here. The first one is the range. You see, range tells us a step order of numbers. If I say range 1, 10, I'm actually going to get the answer 1, 2, 3, 4, and I'll get a range of answers starting from one point going to another. The second part here, you don't have to really worry about that much right now. This is just a variable called a list of items. It's when we can store more than one thing in a variable, and we'll get to that maybe later on. Right, or if you look at the past videos on Teen Geek's YouTube site, lists, I've done lists there. Right, so the first thing we're going to do, since we're going to have to be working with the looping structure, is you're going to have to learn about the range function. The range function allows us to repeat items. So I'm going to quickly open up a program, file, new, to show you what range does and how it works with looping. So if I go, and with the thing about range, we don't have to actually import anything. It's built into Python. So I'm going to go, okay, or, and I'm going to go, okay, let's say number in range. And I put down the number 5. What this will do, it's whatever's going to be indented in my work now is actually going to be repeated 5 times. So if I go print 1, I run this program. Notice range. It displays 1 5 times. 1, 2, 3, 4, 5. Reason for this is because you see range 5 is actually giving me the numbers 0, 1, 2, 3, 4. That's 5 numbers, if you can see. When we start from 0. And it works similar to random. It will stop 1 less than the number that's given. So if I look at this, what's happening is the numbers are actually being stored in this number. So what's happening is for number in range 5, go. For number is 0, print. For number is 1, print. For number is 2, print. For number is 3, print. For number is 4, print. And because of this, I can then go and say, okay, by showing you that the number is going to be stored, you'll see that the number is now going to change to 0, 1, 2, 3, 4, because that's what's actually happening in the for loop. Oh, yeah, here we go. 0, 1, 2, 3, and 4. You see, that's the first part of range. We can have it going from 0 to the end of the number, or just like the random function itself, I can say, okay, for number in range, and I can go 1, 6. Say, okay, if I look at 1, 6, this would actually be 1, 2, 3, 4, 5. Won't go up to 6. It'll go 1 less than the number that's given. So now I can go, okay, let's see what this looks like. Hold on, mustn't forget that. Run. There we go. First time it ran 0, 1, 2, 3, 4. Second time it ran 1, 2, 3, 4, 5. So whatever's inside this looping structure is being repeated. So we're going to use that to change a little bit of our code. And remember, I said we're going to come back to that game that we created for rock, paper, scissors. So I'm going to open up that game again and say, okay, this only works, remember, one time. But if I wanted to, I can make it work more than one time by simply saying, what must I repeat? If I look at it, I want to repeat the person's choice, and everything else after that needs to be repeated. So if I put this all inside the for loop, it'll all be repeated more than one time. So I can make the game run more than once in a time period. Right, before we get into that, let's look at the last part of range. The last part of range is for number in range 1, 10, and I can give it a third value. The third value tells it what we must count in. So in this case, we're going to get outputs of, let me just close up the other shell. So we get a new one. Right, so we get values of it's going to start off at 1, but because it said count in twos, the value after 1 will be 2. Value after 2 will be, why I'm saying 2? 1 plus 2 is 3. The value after 3 is 5. The value after 5 is 7. Value after 7 is 9. And now we can't go to 11 because we told the computer to stop at 10. And the value that's less than 10 is 9. So it doesn't go to that part. So it's only going to repeat it 1, 2, 3, 4, 5 times. So if I quickly go, I left at the colon, so I didn't get indented. So I can go print. I can go number. Just so that you can see the separations, I'm just going to print a blank line on the top to show you that it's separated. The different work. Otherwise, it all looks like it's together. Right. So the first time, the numbers should be 0, 1, 2, 3, 4. The next time it should be 1, 2, 3, 4, 5. The next time it should be 1, 3, 5, 7, 9. That's probably to start at 1, to increase by 2 every time. Let's look at it. There we go. 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 3, 5, 7, 8, 9, because it's increasing by 2 every time. And yes, I can change it. I can tell it, okay, start off at 2 and then count. So it's going to go not 1, 1, 3, 5, 9, go 2, 4, 6. And now it's going to count in even numbers. There we go. 2, 4, 6, 8. But you notice it stopped at 8 because 8 plus 2 is 10. Yes. And according to our format, we're not allowed to go past 10 or equal to 10. It's always 1 less than the number. Right. So that's the range function. Range has a start position, a stop position, and a step position. But of course, I showed you that we don't necessarily have to have the start and stop all the time. We can just put in one number. That's what I put in on our program. Range 5 gave us the outputs. Right. Just that in the last part here, when we're dealing with steps, always remember that that last number step means what we're going to increase our starting number by every time. So that means if I start at 1, 1 plus 2 is 3. And I can start it at any number and I can step it in any number. I can even go a step in 3s. It'll still work, but this time it'll count in these then. There you go. 1, 4, 7. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. But according to our loop, we're not allowed to go to 10. It's always 1 less than the number that's given. Right. So that's what we can do with the range function. So let me just close this slide. There we go. So if we look at that's the range, let's look at this. First problem, display multiplication timetable of an entered number. So if you know what a multiplication timetable looks like, you forgot, this is what it looks like. Example, if I enter 2, I get 2 times 1 is 2, 2 times 2 is 4. So basically, if I look at this, I can say that there's something that is being repeating. And if I look at what's been repeating, I can say I've got a number times a counting number. So if you look this pattern here, we have, it's going to go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to start off at 1 and it's going to go up to 10. So I got a number that's been entered. It's the number that's been entered. That's a counting number is equal to the product. Product means take the first number times it by the second number. So if we look at this, we can run a for loop for count in range 1 to 11. what's going to happen? The values 1 to 10 will be stored in count. So count will be 1, count will be 2, count will be 3, count will be 4. So count is actually now keeping the variable what's going to be there. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The reason why it's going to go 10 is because we said 1 to 11, and it's always going to be 1 less than that number. Right. So let's try that out. Let's open the shell. File, new. Okay. Let's start off with a simple one. So I'm going to go num. I'm going to go short form. Num is equal to 2. Say num is number. All right. So that I can use short form in my code. I can then say, okay, for count in range of 1, 11, I need to do some work. And what's the work I need to do? Is I need to find what the number times the counting number, because remember this count over here is actually going to be counting from 1 to 10. If I go 2 times count, since count is 1, say 2 times 1. When count is 2, we say 2 times 2. I can go, okay, product is equal to number times count. And now that I've got the product, I can go to the next line and print my information out. And say, okay, print it. Print number, let's go with string number plus, and I'm going to put an X there so it looks like multiplication, because not everybody knows that the asterisk key is actually multiplication. So the number times and the counting number, so it's going to be string again. The counting number is going to be count, because count is going to go from 1 to 10. And then I can go, okay, this is equal to, don't forget signs. And I can say string product. And if I run this now, here we go. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Remember, because I put count here, every time this repeats, it's going to say that count, and count is going to be 1, count is going to be 2, count is going to be 3 until we end it off. Right, so that's that program done. Of course, if I wanted to go 12 times table, all I do is change that to 13, because now I have to go 1 to 12. There you go. And the last thing I need to do is change it now from 2 to an input. So I can go inputs, enter in a number, convert the number into an integer. Now the user can actually use the program. So enter in a number. I want 7 times table. Here we go. 7 times 1 is 7, 7 times 3 is 14. We got our timetables sorted. So now we got a program that can display timetables for us. Going on to the next part, which is another problem. Find the average of 5 numbers. Now, in order to find the average of 5 numbers, you must say it's really easy. All you have to do is just find the sum of the numbers and divide it by the number of numbers you got. In other words, since I'll have 5 numbers, I'll add up all 5 numbers and divide it by 5. So if we create a program for that, I can go, okay, let's start with number. is equal to input. I'm going to show you how we're going to change it after this. Number is equal to input. Enter in a number. I can go, okay, sum, let's convert it first. Number is equal to int number. Now let's find the sum. So the first thing I'm going to do, go back to the top and say sum is equal to 0. The reason I'm doing this is I want to make sure that nothing is saved in sum. So starting off at 0. I can go sum is equal to whatever is in sum plus the number. So what this will do, it'll take whatever the number is, you add it to sum because it said whatever's in sum, currently sum is 0, 0 plus the number. Now, if I wanted to do this for 5 numbers, I'll need to copy and paste this down 5 times. But since I know how to use a for loop, I can just simply write out this as a for loop. Say, okay, for count in range 1, 5, sorry, 6, or I could have went simply with 5 there, would be 5 numbers. So 1, 6. I need to repeat this. And what do I need to repeat? I need to repeat all the steps. So I'm going to highlight everything and press tab, and it indents it for me. So all the steps is now in the for loop. So how many times this is going to run? It's going to run 5 times. If I run this, there you go. Enter a number 3. Enter number 5. Enter number 23. Enter number 4. Enter number 5. And that should be the last one. I've got the same thing entered down 5 times. Why? Because I put it in a loop that's going to run or repeat whatever's inside the loop 5 times, because I said 1 to 6, which is 5. And finally, on the outside, I can go average is equal to the sum of the numbers divided by 5. And the reason I put this outside the for loop and it's not indented is because I don't want to keep on dividing sum by 5. We only divide the sum by 5 one time. So it's always important to know what you are repeating. So if we do this 5 times, I can now say print the average is, and say, right, the average is plus string average. Run this, enter number 6, 5, 6, 7, 3, 2, and there we go. If we add up, right, if we add up all those numbers and we divide it by 5, we get 4.6. So we created a program to calculate average. All this wants for you to understand that the for loop repeats whatever's that's indented that many times. Right. Right. So if you think you understand that, how would I do it for 100 numbers? So if I look for 100 numbers, yes, all I do is I change it from 1 to 6 to 101. So it makes life easier that we don't have to continuously copy and paste. That's why instead of copying and pasting 95 more times, we just change the looping structure. Bring it back to that little game that we had. So if I wanted to do this entire game, where's the game? I'm just trying to find the game. I close it. There's rock, paper, scissors. Okay. There we go. So if I wanted to play this little game with us and they wanted to do it more than one time, I need to know what I need to repeat. And we know that we need to repeat all the steps here, because every time a person enters a number, I need to check that number and who won it. So if I need to check who won it, I'll also need to figure out that the computer has to get a number. And because the computer is getting a number, also the person has to enter in a number. Feed in. All right, so this entire code here has to be repeated. So what I'm going to do is I'm just going to highlight it. I'm let's highlight it. And I'm going to press tab to push it in. And at the top of the code here, I'm going to say for I in range, and I'm going to go 3 times. This entire loop here will go 3 times. That means this entire, it'll ask me 3 times to enter in a choice. And every time it asks me to enter a choice, all the code beneath it will also be repeated. All right, so there we go. So if I run this now, oh, invalid syntax, I forgot the colon. So now I got the game. Let's pull it up. Enter in your choice. So the first time, let's say I chose rock, the computer chose rock. I actually went to the rock. All right, sorry, the computer won. But you see, the program didn't end. It's asking me for a choice again. So I can choose another choice. Maybe I chose paper this time. And you'll notice that there was no output. The reason there was no output was because I didn't code what happens if the both choices were the same. So that means in this case, I chose paper and the computer chose paper. So lastly choose again. This time the computer selected rock and I beat the computer. So I've actually won 1 out of 3 times. So I can create a program that can also keeps track of score for me. Right. So that's the end of today's lesson. And Lee arc. So right. So if I look at the program again, yes, the one program. The links for your projects have been changed. So I'll just share that with you just now. It's the one program you're looking for again. Oh, it's at the top. Right. In order to work out percentages, your percent, in order to work out what your percentage is, it's always going to be what you have for a test over what the maximum for the test is. So if I look at a mark, so if I say I've got 25 out of the maximum mark of 50, so it would be 25, what's my mark out of 50? And the end of it, because we want to convert it to a percentage, we say multiply by 100. Because we say multiply by 100, we can now put in the percentage. Because whenever we see a percentage, it means divide by 100. So because we multiply by 100, put in the percentage. So I multiply this by 100, I would see that I've got 50%. Sorry about that writing. Trying to write with the mouse on the screen. All right, so I've got 50%. So that's how we work at percentage. It's always what you've got over the maximum. All right. The last thing I need to show y'all is the links. Okay. The links for your projects, those of y'all that registered, is as follows. So again, so I'm just going to copy the links and put it into chats. Find it. There we are. So with this, when you upload in your projects, please remember that I'm sure it won't be more than it. but your project can only be a maximum of 1 gigabyte. So for grade 8 to 9, the link is there. Right. Copy link. Grade 8 to 9 to where to upload your project, and to upload the project for 10 to 12. The link. That's where you can upload it for 10 to 12. Again, the maximum size for a file is going to be 1 gigabyte. If we look at all the files that we coded, even in the little program that we did with all the repeat statements, doesn't go more than, this is almost 2 megabytes. That's it. So you'll have more than enough space to upload your project. Again, remember after this lesson, the start shown one more time. Right. The link for the talk that's going to happen again. The web development programming talk. I'm going to link that now again. Remember, you can join and create websites and with this following link, and you can actually create the activity behind the websites. Please join us at 4 o'clock on that. Thank you for joining us today, and I hope you have a restful weekend and a good school term next term. Goodbye.